Yeah, welcome back again. It's another edition of this machine learning training. We are looking at unsupervised learning. So we want to look at another algorithm under unsupervised learning called mean-shift clustering. Last time we looked at k-means clustering, and we also look at how we can select our k in k-means clustering. So which we have covered so far in the last two sections. So this time we want to look at this mean shift clustering and how we can also implement it in Python. Okay, the mean shift clustering is a non-parametric clustering algorithm that works by iteratively shifting the mean of a data point towards the densest area of the data. The densest area of the data is determined by the kernel function, which is a function that assigns weights to the data points based on their distance from the mean. The kernel function used in mean shift clustering is usually a Gaussian function. The mean shift clustering is a density-based clustering algorithm, which means that it identifies clusters based on the density of the data points rather than the distance between them. In other words, the algorithm identifies clustering based on the areas where the density of the data point is highest. Now, I've done a little intro to this particular algorithm in the previous section under the introduction to unsupervised learning. So what we want to look at the application of this mean shift clustering. Number one is computer vision. It's widely used in computer vision for object tracking, image segmentation, and feature extraction. Also in image processing, it's also used for image segmentation, which is the process of dividing an image into multiple segments based on the similarity of the pixels. Also, we also have anomaly detection. This can be used for detecting anomalies in data by identifying the areas with low density. Also, customer segmentation. This can be used for customer segmentation in marketing by identifying groups of customers with similar behavior and preferences. Also, in social network analysis, can be used for clustering users in social networks based on their interests and interactions. Example, in YouTube, in Facebook, on Facebook, likewise. So that is how, or in TikTok, all those ones. So it can be used. So how do we implement this particular algorithm? We're going to generate a data which we have used before called blob, make blob dataset. So we're going to generate it here as usual. So we create a dataset, three blobs, three clusters. So using make blobs. So I want to run when I run this now, and it's going to give me this particular cluster. This data set I'm going to call, but I'm going to just quickly visualize the raw data first. How it look like. So we have three cluster right already. The points are colored by their true cluster label. And we have three here, so you can see here. So that's a rough sketch on the data visualization on what we want to work on. All right, so now we can apply our mean shift now, because mean shift automatically determines the number of clusters by finding the peaks in data set density. Now, don't forget that in other k-means, we have to manually determine our k, okay? But under mean shift, it's automatic. Mean shift automatically determines the k by itself. So you don't need to supply number of k as you do in k-means, all right? So that's one of the major difference between k-means and mean shift, all right? So we have to apply mean shift, which initialize the data called our mean shift here. We import it here. Then we have to let's create ms for mean shift. We call the function. pass in the bandwidth, which is equal to 2. So bandwidth is equal to the radius of density search window. Okay, so we fit in our main sheet, we fit in it here, then we get our result labels equal to ms just label, call the label. So we call the cluster also, and the number of cluster is by default is automatic. So we're going to, if you print this particular number of cluster now, you're going to give us 3 just to see how many cluster it is. So this one is not just to show you an sample of what I'm talking about. So estimated number of cluster is 3 already. So we didn't put the 3 there. It detects that automatically by itself. So now we can visualize it. Now we run this code now to give us a visualization of this cluster with their centroid. Okay, so you can see here, so number of key has been determined 3k, and with their centroid here, so you can see the centroid between them. So now the colors are clusters, and the red X automatically detects the cluster centers. So we have major 2 key parameters here. We have bandwidth, which is radius of the density search window. So use estimate window, which you see in the next segment. I also have bin seeding. It speeds up the computation by seeding the centroid in a grid. We set true for large data set, but for now we didn't set anything called bin seed now, because the data set we are using is not that too large. So if it's large, we can pass in our bin seed. Okay, we set it there large. Okay, so now automatically estimate bandwidth as well. Okay, so you can see bandwidth which we are talking about now. As I should see below, this is bandwidth here. Automatically estimate the bandwidth. So which is a lower quarter equal to fewer quarters. So here we have a bandwidth 1.49 estimated bandwidth. So we just want to see the bandwidth we are talking about now by calling our estimate bandwidth function and pass our data set, then quarter to 0.2. Okay, so and we can evaluate the true label here, performance here. We can evaluate it here to see. Alright, so we put our adjusted rand score to see. When we run this now, we pass it the score, while true, and labels used to it. So we round it off for two decimal places, give us 1.00. Okay, so let's adjust rand score. This is very high. Then how mean sheet works? Number one, step 1 rather, for each point, calculate the mean of all points within its bandwidth radius. Okay. Number 2, shift the point towards the mean, toward this mean iteratively, and converge to cluster center mode of the density distribution. So this is what it called, it converges it again. This is what it does. And when to use mean shift. Number one of the pros is that no need to specify k or to detect k, which I explained previously. And also it handles irregular cluster shapes. Some shapes are very irregular. Okay, they are not standard shapes, so you can handle them properly. And it's very robust to outliers. So even though your data have outliers, it can handle it properly. And one of the cons means that computationally expensive for large data sets. So it takes a lot of time to process, relative to bandwidth choice, and struggles with high dimensional data. So these are the merits and demerits of this particular algorithm. So, but all the same, it's very interesting and very powerful. So k is equal to 3 now. We don't select k, we give us k by itself. So this is just basically what a mean sheet algorithm is all about in clustering. So we are going to see more of these algorithms as we journey in this particular training step by step. So I will see you in the next class. Thank you so much for listening. See you later. God bless.